Hello everyone. I'm Karthik. If you have not seen me, I'm in Thoughtworks for last 3-4 years, I think, and I'm playing a TL role in one of the accounts in Thoughtworks. So today we are going to see and explore things that we can do with Docker, like how to secure things and how to make it more optimized. There are some techniques that I'm gonna show you today. I want to highlight this thing I love to watch tech talks. One of the things that I listened to was Jeffrey. Some of them consider him as a father of AI. So he pointed out something last week that, like, in one of the tech talks, this introduction of AI that's going to be huge in respect to how things in the secure platforms, like we are going to see a huge spike in number of vulnerabilities that's been created in upcoming 1 or 2 years. So there are going to be a lot of challenges in terms of securing things, making it more vulnerable prone to the outside hackers or threats. So yep, let's get started. Yeah, so some of the problem statements that we have, like frequent vulnerabilities that you would see day to day. One of the things I would like to highlight is when I joined one of the projects, I there was always a card in the sprint which is to patch the vulnerabilities. So I don't know how we predict that. Like every iteration will have a card like, let's fix this vulnerability. So that's something I always wondered, like, how did we end up something like we predict some work that is going to be coming in the next week without knowing what we have to do. So that's one of the build and runtime stages in one of the Docker file. If you see, there is a lot of upgrades and installs that we do for a particular libraries. And I always wondered, why do we need to do it? Why do we need a library called ziplibc, Python, expat, libxml in our Docker images? So we'll see it in the later slides. But these are the things that I always wondered, like, why did we end up adding these libraries part of our Docker, and we kept on patching on weekly basis. And one of the nightmares that we're gonna always see is CVE at the production on the production day. That's going to be where you have to go to your root cause analysis, figure out what the CVE is, and figure out what we have to do with this, and go to the security team and get some buy-in, or like, let's go and fix this. So on the day you will go on production, but obviously have never tested these CVEs before, so these fixes before. So that's one of the nightmare we usually end up doing if you have having a lot of these libraries part of your Docker images. And obviously it includes your im- it also leads to a large image sizes. Some of the sizes may vary from like 500 MB to 700. So the image sizes are not a problem, but it ends up having a lot of issues in your build chain. Like, you will end up having to pay a lot of money in your storage cost. Your build time gonna take time. Your scanning of the image would take time, and deploying it through the Kubernetes gonna take time. So all this will end up having these images, these libraries as part of your Docker images. And one of the other problems are staying up to date. So as I said, like, we'll keep on having these vulnerabilities weekly, and you have to go and fix it. So how do you choose a right Docker images? That is also one of the problem statements we wanted to address as part of this session. And obviously, larger image size can lead to a slower startup times, memory footprint, and we also gonna talk about how do we observe, like, let's say we address all these problems, how do we observe these things as part of your production. So these are the things that we're gonna uh, discuss today. I'll go with some of the things need to consider. So choosing an image should be a straightforward thing, right? But when you look at from the project scope, from a squad scope, it is simple. But when you look at from an enterprise organization level, it's always complex because you have to consider these four things, like what are the security implications have. For example, vulnerability surface, like how many any image, any package that you include as part of your Docker has to be monitored and has to be patched. And updates cadence. For example, if you choose Alpine, the update cadence is like they usually update their vulnerabilities like in a weekly manner, whereas if you go with Ubuntu LTS, it's going to be monthly. Again, a privilege requirement, some of the Docker would require you to give a root access, some of them are not. And how do you manage this supply chain security? So again, these are the other considerations like technical, like how do you improve a startup performance, memory footprint, CPU usage, build time. Similarly, in the operation challenges like how do you going to monitor these the images that's been used within your entire organization? How do you going to manage it in the CI/CD pipeline? And obviously, the main problem in the enterprise organization is standardization as a specialization. So some of the organization may say that, hey, we need all of them to use a one Docker image, but it may not work for you. Whereas in some organization, they go for choose a Docker image based on what your application requires. For example, if it's needed as quick start time, then go for this. If you need a performance over a time, like it's a long running application, you need a performance over a time, then go for this particular Docker image. So these are the problems that the enterprise organization may face. Again, there are organizational factors involved, like whether the developer has a familiarity with the Docker image that you choose. Similarly, how much maintenance they're gonna have, and knowledge gap, because we never see the Docker files, right? In the sense of optimization. So how do we just choose the image? How do we go beyond that and like figure out what are the optimization techniques you go and like import in your Docker files? So these are the things that we're gonna try to address. So let's go. First thing, what we're gonna do is like to choose like what are the things available in the market and what you can choose is from them. So one of the major aspects of the first option is if you are already in an ecosystem like Amazon or Azure or Google platforms, they provide a very good optimized Docker files, Docker images. For example, Amazon Corretto is one of the image from the Amazon itself, and it is optimized for their services. So if you deploy it in EC2 or their EKS cluster, it's going to be faster. So, but it comes with a lot of problems. As I said before, like it provides you a lot of libraries inbuilt. And they don't patch it like weekly. So they have to like since Amazon is a very big organization, they have to go through all this process. Like when a vulnerability comes in, they go and verify the root cause and then they fix it and they will put it in the pipeline. So there is a huge process. So if it is highly critical, then you have to like, let's put on hold, like let's wait until Amazon Corretto's latest version comes back. So this is one of the major limitations that we go with Corretto. But as I said, it's optimized for Amazon services. So if you are having your service always deployed to Amazon, then this would be a right candidate. And also it includes shells, tools, which are not required at the runtime. As I mentioned, like it's a larger image size, which means it has a larger attack surface. And one of the main problem is vendor lock-in. So if you are in Amazon ecosystem today, and what if you move to another or a hybrid where some of your services have to be deployed in Azure? So this may not help you. So you have to figure out optimized version for that another cloud provider. So what are the other options? We can go for base image alternatives. For example, Eclipse Temurin or Azul. I've seen one of their recent tech talks from Azul that they have improved 30% in their startup time with their new JDK version. So you can also try it out some of these. So it is really good for greenfield projects. We are currently using one of them in our greenfield project where we started with Temurin. Now it's really good that We usually get to have a CV like every week or at least one in a sprint. Now we haven't seen like almost for 3-4 months. So this is really good in terms of like when to choose a right image, right? In this case, like it's a green field, so developers doesn't want to go and like figure out what are the CVs or like any build complexities. So there are some options we're gonna see which involves a lot of complexities. So these images are very simple to use. You can just plug in, it will work like a charm. So I've also mentioned like what are the things that you would add when you build. So it base images like they work on top of Alpine or Debian, and then they would have this Java runtime on top of this. So as I mentioned, though, some of the pros are like it's vendor neutral. So if you are working on a hybrid cloud providers, then you can obviously go with an this options, and it also supports broader platforms architecture like x64, arc64, and it is certified TCK. TCK is a technology certifications that will be provided by the Jakarta EE. Like you have to be compatible with their version. So that's when they will provide you this TCK. So this is something they are provided. They have it in their bucket. And also they have flexible OS options like Alpine, Ubuntu, Debian, etc. And one of the limitations is since it is maintained by someone, so if there is any vulnerability fix needs to be done, so it is obviously they have to do it first and then you will get it. It's not like you can go and fix on your own. So something you have to like rely upon them. So it's really important to choose a right vendor in this case. So there is one more options that we have, which is to trim down Java. As part of Java 11, the Oracle has mentioned that they are moving away. So if anyone used Java 11 or before, they used to provide two different things. One is JRE and one is JDK. So people used to use JDK during development and use JRE at the production environment. Whereas after Java 11, they have bundled it together. So JDK and JRE comes to one package, but they've introduced a concept called modules where you can like strip down modules that is not required. So in this case, like you can choose your own Alpine image. Alpine is the most secure one. I mean, available in the market where its total size is almost like 5 to 6 MB. So there are very less packages that's been introduced part of Alpine. And on top of it, you can build your custom JRE using this JDEPS and JLink that's been provided by the Oracle. So which comes around like 40-45 MB, then you can put on your application. This is one of the most like lean and lightweight uh, options that we have seen so far. But again, it comes with limitations, right? So Alpine is built on MUSL versus whereas the other Debians are done with libc. So if you have any dependencies that needs to be talking to a native libraries, then Alpine wouldn't work for you because you will face a compatibility issues. And similarly, like since you are gonna trim down a lot of modules from JDK, how do you do it? So you have to analyze your jar file, figure out what are the modules that are required. Then you have to inject it as part of your custom GRE build. So what if you missed one of the modules? What then? Like you can't find it in the build. So you have to find it during the runtime. So if you don't have any end-to-end coverage or tests, so this will so you'll as the meme says, like you'll stuck in a river, so you have to go back and figure out what happened. So we have come so far with three options, and this is a fourth option. This is something that's getting really popular in the recent days, distroless. This is from the Google, where it's again Alpine or Debian that you can choose, but what they have done is they've removed the package manager and shell completely from the Alpine or Debian. So which means you can never go into the Docker console. You can print something, you can debug something. You can never do that. What is the main reason? Because in production, you are never allowed to go into a containers terminal because you will inject a lot of environment variables such as your tokens, access code, token to hit a payment APIs. So all this would be part of your terminal. So you will never be allowed to execute any commands in your Docker. So that's why it's restricted. But what they have gone into is like they have removed this package itself. So you can never do this. So this is the most secure one. So if you are in a healthcare or financial uh, ecosystem where you want the security is the first thing you want to do, then you can obviously choose this candidate. Obviously, these are the limitations as we discussed. Like it's very difficult to debug because you will never get a chance to log into a Docker terminal, and it requires a multi-stage build, and it can be challenging to add temporary tools because all of the package will be removed. So it's really hard for you to go and do any of the stuff. So you have to do it before the runtime stage in your Docker. And the fourth is the development complexity. As we always do, like, there are a lot of things that we experiment. So we can't like, no, sometimes you need this debugging tools, right? In your development. So then what you have to choose is you have to choose a base image as alpine or some other images in your development environment. Then you have to use distorless in the production environment. But then it comes with the problem of it works in my local and it is failing in the CI/CD or another environment. So these are the some of the limitations with distorless. And obviously, uh, if you want security, utmost security, then yeah, you can choose this one. Then this is something new feature from Docker itself. So it's available only in the enterprise edition. This is really helpful for big enterprise organization where they want to control the number of images that's been used by the teams in the enterprise organization. So again, it can be used in the finance or healthcare or government, and I can quickly show how it looks like. So you will have list of images and you can create your own image, but then you can also choose which are the package that you need to be included as part of the image. Then organization can choose and create, okay, this is the image that my entire organization has to use. You can create like 2, 3 flavors like Alpine, Debian, or whatever the that suits your ecosystem. So this is one of the biggest feature that's recently introduced in Docker. So this is something we also like trying to inquire like how we can use. This is really helpful when you want to control the number of images. So this is one of the candidate, like if you have like very regulated environment where things has to be audited and has to be in compliance. So this can be one of the candidate that you can choose. Some of the limitations can be complex to configure, may have stricter runtime requirements. You also need a paid subscription. As I said, like if you are already in the Docker enterprise license, then it's not a problem. And it can be larger than standard images because they also put in a lot of libraries to make sure things working fine. I think till now we have seen based on the JVM and how it works with Docker, and obviously we wanted to cover this slide as well. Like since this is getting a lot of attractions in last 2, 3 years, where people are moving towards native images. If you ask me, like this is mostly used when you have like serverless functions, lambdas, because it has a very good or faster startup. and and there is two philosophies, right? Like if you take traditional JVM or Docker, means the philosophy is like I will optimize at the runtime. So JIT compiler helps us to optimize things at the runtime. So if JIT compiler goes and sees instruction, it will identify a pattern. Like for example, it will take a instruction and like tries to analyze 1 to 100 request. Okay, this is the pattern it sees. It will try to optimize it for one, not 101th request. So that's why the traditional JVMs are used when your application is longer running, because that will improve your performance over a time. Whereas the philosophy of Graal VM is I will optimize everything at the build time. So I don't want any of this complexity during runtime. So which means you have to do a lot of configurations, and the advantage or the value you would get it is the near instant startup. Like within a second, it will just quickly starts up. For example, if you want order service, for example, which has to serve millions of requests, you can just instantly start up and create instances. So it's recommended for serverless and fast function as a service, like AWS Lambda or Google Cloud Functions, and obviously high density microservices. For example, as I said, if you want to create order service which has to be a instant startup, then you can go for this. Again, CLI tools, or like if you are building your data pipelines, you want like immediately has to be startup if you don't want a cold startups kind of situation. And also it optimizes a lot of things at the base OS. If you look at the base OS is like very minimal, and it has the native executable because it will not have the Git compiler. As I said, they don't use Git compiler at the runtime, so it removes all those Git compiler, code cache, metaspace. So they remove a lot of things from the native executable. But what's the limitation? Obviously, everything has a trade-off. So this one has longer build times it will because you have to like build the image during the build. So basically, you have to like analyze all your code. If there is any reflection used, you have to like add those configurations. So there are a lot of so I've used in one of the CIC, like experimented in one of the CI/CD pipelines where the build was 3 minutes in the traditional JVM, and it moved to like 7-8 minutes. So if you are okay with a build time, then yeah, you can use it. And also there are a couple of issues. I'm not sure you can see them. There is one called closed world assumption that you cannot use dynamic classes when you go with Graal VM because everything has to be defined at the build time. So you can't go with the dynamic classes. So that's one of the problem, and also the reflection hell, where if you look at the current Spring Boot applications, you use ORM or like any ORM like Hibernates, JPA, you will be using it heavily. So that is not supported natively in Graal VM. So we have, because they use reflection like anything. So if you want reflections to be used in Graal VM, then you have to like set up list lot of configurations, right? I'm not sure. I don't think you can see it, but you have to like create a lot of configurations, and which are the classes that uses reflections. You have to specify them. So it's a bit difficult, and also it's a mindset change, as I said, in the philosophy itself. Like if you want to optimize at the build time itself, then this would be a right candidate. And it's maturing. So there are a lot of frameworks like Micronauts, or even there are Spring native uh, projects are being built. So till now we have seen a lot of Docker images, when to choose and what are their limitations. Hope I was able to give you a bit of understanding on when to choose things. So as I said, if it's a secure first, go for Distroless. If you want instant startup, you can choose Graal VM or like trimmed down GRE. Or if you have a memory constraint, you can go with custom GRE. Or if you are working on a Amazon ecosystem, go for Amazon Corretto. So there are a lot of things in the marketplace. You can do the trade-offs, which one of the service works best for you. Like you can choose one. And mm, so we have done choosing the right images for us. Then we are going to analyze or see some techniques like how we can improve things from here, right? So one of the tool I've recently found is called Dive. It's a plugin. It's a open source where you can download and analyze your Docker files. So as soon as your build is complete, you can download this plugin and you can analyze this image. It will give you a list of layers that's been used. If if you don't know what this layer is something like the Docker creates on any instructions that you run in your Docker image, and it caches it. So if you have less number of layers, that's gonna help us you build your images faster. And you don't have to change the layers a lot, so that makes it the cache more reusable. So this is one of the techniques where you can analyze, and it also provides you like where are the places you have wasted bytes and what are the percentage efficiency that you can gain. So one another technique is enabling generation mode as part of Java 21. As I've added these two examples. This one is from the Java 11, where this is how the heap is maintained in Java 11, where you will have a single heap space, and your new and medium or old spaces are there in the single heap space. So every time a garbage collector runs, it just iterate goes to each and every object that's been created in the single heap space. So that's when they've revolutionized in Java 21. So they introduced something called generation mode, where it first created, whenever the object gets created, it has the age 0. And whenever the next GC comes in, if it still stay in the heap space, its age goes to 1. And even in the second stage, if it comes to the GC and says, oh, okay, you are still there, so I'll increment it to H2, which is survive GC. And once you have done enough to long live, then it will move to a older generation where the GC happens very rarely. So in the new GC, in the young one, you will have the frequent GC happening, but also they've introduced a parallel GC. So before Java 11, they used to do blocking threads. So they block the entire threads in the application, and they do the JC, which means it will have a spike in your latency. Some of the requests will be in, like, for example, 1 second, and they block some of the threads. I think most of the threads, and it will get you a spike like 1.5 seconds in your next request. So that's when they have improved in the Java 21 and 11 as well, where there is no more thread blocking, so it happens parallelly. They've created a new table where it will tell you whether the things are moved or not. So this will help you. No, this will help them to like garbage collect things efficiently. So this is one of the techniques that you can use. Like you can enable the generation mode as part of your Docker. So one of the other techniques is dependency analysis plugin. So this will help you understand what are the libraries that you've used, unused, and what are the scopes you have to modify. So this will help you reduce the number of dependencies that you have been created so far. And obviously, depend about auto merge. As I mentioned, like we end up having a card in every iteration to patch the vulnerabilities. Now, with the introduction of enabling dependabot and auto merge, this helped us to not look into what are the things we need to patch. So it automatically creates a PR for a minor versions and runs all the test, quality gates and everything. If everything okay, it automatically merges into a development environment. After dev, you will have smoke test and end-to-end test, which covers all your scenarios. Obviously, for the major versions, it will ask you for review. Once you're done, it will help you like merge things and deploy to your lower environment. This is one of our DX reports that we recently saw. So auto merge in our project helped to save like almost 10,000 in labor costs for 4 months or 5 months of time, which is eliminating like the manual patching. So I highly recommend this approach. If you have a streamlined CI/CD where you have all the quality gates, tests, end-to-end tests, and smoke tests. So we have seen so far on the how to choose a Docker file, what are the techniques to analyze, and how to improve the efficiency and performance. And now comes the observability part, where there are endpoints that's been already available by the actuator in Spring Boot. So you can just enable them. and you can create some tools, not create some tools, you can use some tools like Open Telemetry or something where you can pull in all those JVM metrics, send it to a dashboard. So you can monitor them, like whenever there is a spike, you can just go and see why it happened. And if tracing in enabled, that will also give you which business case or business rule took long time for you. So that's bit on the slides. I'll quickly show you some of the codes. It's there in this GitHub repo. I'll quickly show you how it look like. Oh, this is not visible. Sorry, second. I closed it. And presentation. I think it's better now. So what we have done is we have created a test script. Obviously, agents helped me to create this in 5 minutes window where I've used all those combinations that we have seen so far. For example, a traditional Docker image, one with Alpine, one with Distroless, one with Slim JRE, like trim down all the JDK modules, enabling generation mode. And also I want to highlight, like if you're using your Docker file, always create a user, non-root user, and then start your application, because that will help you prevent the application to access your host with a root access. So that's one of the security problem that you may face if you don't provide a non-root user to the application. And these are the metrics I've tried to collect. So heap used, non-heap, GC collections, when happens, thread count, classes loaded. So I'll share you this GitHub repo. So you can like always use all these metrics to compare things. And obviously I've used it in an order service, but I think it's very simple. Like it has only one endpoint. Like if you have your actual service, then you can try this out with uh, different files, different Docker files, and you can able to figure it out. So let me go. So this is the result that we have got. And as I said, like these are the memory efficiency that you can see that JRE Slim has the least, or having the less size compared to traditional ones. And also I've tried to capture the CPU usage. What I have tried was spin up a test, run this Docker, do a load test, capture all this JVM metrics, and end the test, and do this repeatedly for all the Docker files. And it creates you a summary of like what are the things that went well, and what are the performance rates, what is the size, what is the CPU limit. So I think whatever I got is very pro to Distroless, but I wouldn't take this, because the service is very small, and it's not like one that we usually use it in our application, in your projects. And also there is observability part we discussed, no? So you can also use something like Prometheus and Grafana, so where you can send this metrics. So what I've tried was I've set up this Prometheus and Grafana in the local. So your JVM metrics will be sent to Prometheus has this time series database where it collects all those data in a time series format, and Grafana is used to show all this data in a dashboard or graphical representation. So in this, if you've seen, like, not sure you are seeing the spikes. So this is basically the objects getting created, and there is a GC happens, which the heap size goes down, and obviously it tries to create a lot of things, and GC happens, it just comes down. So you can monitor all those with your observability dashboards, and you can also set up alerts in case if something goes wrong, you can like get notified. And if you have enabled tracing, that will also help you, like which exact scenario or business rule that caused this spike, so which you can just go and like figure it out what's happened. So yeah, with this, you're done with this session, but I'll ask here for any questions, queries. Cool. If there are no questions, either it. Again, I said there is no one Docker image, but as I said, there are a lot of use cases you have. As I said, if it's a greenfield, we used Eclipse Temerian as one of these startup where you don't need to think about any complexity. You don't need to think about CVs at all. So it depends on the project. Some of the organization will come with their own set of images where you have to use them. So it depends. Eclipse Temurin and Amazon Corretto. Okay, Amazon Corretto used because we are entirely based on Amazon ecosystem, and people are afraid to move away from that because in all other options, if you see from the alpha, and you have to trim down a lot of things like tools that you don't require. So since our account is low risk aware, like they don't want to try any of these. So that's when we are now trying to reach out to Docker itself for the hardened images, since we have like the enterprise license. So we'll probably go towards that direction because we also thinking of building a group platform where we want to use only certain images, like a golden image concept where one image has been created and can be used across the organization. Yeah. Yeah. So that's why if you go for hardened images and if you're trimming down all the package manager or terminals, then you may end up having two different flavors. One in for local development where you want to try to do some experiments, figure out what's going wrong. But as soon as you hit a staging or production, you have to go for another flavor, which removes all those consoles and everything. Yeah, that's true. But it comes with the value, right? Where you, because you will never allow to enter into a production terminal. So that's no. Even if there is something goes wrong, there is no from security. Okay. Thank you everyone for bearing with me.
Thank you, Karthik. So folks, it's time for a short break and we have high tea for your quick recharge.